With the rise of the LLMs, we needed new ways how to evaluate them because they kind of catch up with the evaluated metrics and then be new problems.
Hey everyone, and welcome to a great episode here at Slator Pod. Today on the podcast, we welcome Kocmi and Alon Lavie. So Tom is a researcher at AI Lab Cohere, and Alon is a distinguished career professor at the Language Technologies Institute at Carnegie Mellon University, one of the leading universities in language AI, has been for decades. So we also have with us Slator's own research analyst, Maria Stasimiotti. So Maria covers language AI here at Slator. I'm very happy to have her on. And we're here today to talk about the findings of the world's most important AI translation competition, for lack of a better term, and generally the state of the art in AI translation more broadly. So hi, everyone, and thanks so much for joining.
Hello.
Good to be here.
Everyone.
Cool. So look, I'm trying to give a little bit background to today's conversation. So it's going to revolve around the WMT competition that concluded recently, and we've been covering it on Slator.com quite extensively. So just super briefly, and I will ask you to tell us more about it later on, Tom and Alon, but super briefly, I think the WMT, it stands for Workshop on Machine Translation, and it was initially first held like in the like 2006 or something as part of it was a chapter at the North American chapter of the Association of Computational Linguistics. But then I looked it up. It said in 2016, with the rise of NMT, it kind of the WMT became a conference of its own. So this concluded recently, and you both were instrumental in doing this. And generally, so we want to talk about that, but we also want to talk with you about the kind of general state of the art in translation AI. So now let me hand it over to you, Tom and Alon. Can you just tell us a bit more about your background, how you got into translation/language AI, and your current role? Maybe starting with Tom.
Currently, I'm a researcher at Cohere, where I'm part of multilingual team focusing mostly on machine translation and evaluation. And before I joined like a year ago, and before I was working for 4 years for Microsoft Translator, where I've been leading the evaluation part of the whole pipeline. And so I'm leading the WMT conference, or mostly the general MT share task, where Alon is taking care of the metrics share task or automatic evaluation. So maybe a little bit about the WMT. It's as you said, it's a conference nowadays, and it contains multiple share tasks that focus on different parts of the machine translation, either how to improve the performance of the models, or how to evaluate them, or how to evaluate the metrics. And this year we hit the 20 years of WMT conference.
I've had a pretty long career in this space. And I've been here in Pittsburgh, all around sort of Carnegie Mellon for just about 30 years. But I was here a professor already at CMU for about 20 years. Starting from 1996. My research areas have really focused on machine translation, and over the last almost 20 years, actually. One of my areas has been automated evaluation of translation quality, primarily machine translation, but increasingly, any translation quality that involves automatic translation or human translation or a combination of those. So earlier on, soon after BLE came out in 2002, I actually initiated a research project that developed one of the earliest metrics that was trainable for machine translation. That was the Meteor metric, that was actually used by a lot of people in the field up until for over 10, 15 years, I guess, until the neural era came out. Meteor is actually used beyond machine translation. Actually, I keep being surprised. It's the most cited of all of my research on Google Scholar and on Semantic Scholar. I have immense numbers of citations for Meteor, and it's used in various NLP applications quite successfully. But then in 2009, I had a startup. I spun out from my lab here at CMU, a startup company in machine translation adapted for enterprises, company by the name of Safaba. And long story short, Safaba was acquired in 2015 by Amazon, at which point I took a hiatus from my academic career. I remained as uh, an adjunct professor and continued to do some advising, but I went for 4 years into Amazon as a senior manager for machine translation and ran the machine translation research group here in Pittsburgh for Amazon. And after that, I left Amazon in 2019 and I did two senior AI management, R&D management roles, 2 years at Unbabel, and then for the last 2 years from 2023 until earlier this summer, I was the VP of AI research at Phrase. And then I concluded my executive kind of management full-time role at Phrase early this summer, and I decided to come back late in my career to academia. But along the way, at Unbabel, we launched this initiative developing a new neural age machine translation evaluation metric called COMET, which was widely adopted and is still widely used until today. I think we'll talk about this maybe a little bit later, but I think in the age of LLMs, new technology is already taking over. So I don't expect that COMET will be, the dominant or the primary metric to be used for much longer. But it's done very well and has been very useful for progressing the research for machine translation over the last few years.
Great, thanks. That was super helpful. So maybe before we go into the WMT, I just want to take a quick detour into if you were, or before the kind of LLM revolution, were in the field of AI translation, how would you recap the past 3-4 years since these models came online in a big way? Maybe starting with you, Tom, and then moving to Alon.
I would say like maybe over the last 5 years is the best time frame. So the main topics that's been changing is like the huge progression in the evaluation, where we change a lot of stuff that we've been doing differently. And with the rise of the LLMs, we needed new ways how to evaluate them, because they kind of catch up with the evaluating metrics, and then we new problems. I think another change is mostly about how the translation look like from the LLM. So the style is slightly different. They are maybe a little bit more fluent, and this also affected all of the other parts of the how to train them, how to evaluate them, and everything. So I think the main progress in MT was mostly in the evaluation, or from my perspective, and how to actually find out that they are better, or that the previous models, that they are improving, or it's not just a mirage that humans are biased by the fluency, for example.
I think it's well known, kind of like the generational kind of milestones of the technology, and I was deeply involved in both the statistical machine translation age, where we built dedicated models for enterprise customers, and then the shift, of course, to the neural age around 2015, and then the advent of transformers. So from the early neural to late neural, and then to LLM. But I think the change from neural to LLMs, maybe the most important aspect of that is, first of all, that grammaticality and fluency in most of the major target languages is largely solved. Basically, the problem with machine translation today is not, before, even in the neural age, but certainly, around 10 years ago, if you were using machine translation, you were getting, rough language out there. There were grammatical and mistakes, inaccuracy related to actual semantics, but also just the generated language was completely rough. And so editing of machine translation 10 years ago was a very different type of endeavor than what it is now. Late in neural, things got already much more fluent, but fundamentally we're still translating sentence by sentence. So still, when you're with translators that are working, or any kind of enterprise project that's working on translating a document or a piece of content or a web page, right, had to really worry about how those sentences fit together. And there was still a lot of editing work. But now with LLM and the move to LLM doing the translation tasks, they do it in full context. They generate highly grammatical language, right? It's very rare to find actually grammatical errors. So they do make mistakes, semantic mistakes here and there, but humans, translators, make mistakes all the time. The characteristics of the mistakes that LLMs make are not necessarily exactly the same. But the fact that they're actually so fluent and can generate so much in context, right? And either you can do that nowadays just off the bat and you use a model that is going to generate that type of very fluent contextual language, or maybe for whatever reason, there are domains, and certainly on the commercial space, where people are still using neural models, but then you can use an LLM to basically post-check itself, right? Automatically smooth out and correct and solve things that only humans were able to do before. So in my mind, those are the main, main really radical differences, and it has deep impact on the workflows that are used across the industry. And we're in a transition period of moving from well-established, well-understood, both in terms of like process, but also in terms of economics models of MTPE and post-editing and automated workflows, to LLMs and agents doing various parts of the puzzle. And that transition is quite difficult and challenging to a lot of users and enterprises that use this technology at scale.
I'd like to ask Tom and Alon to tell us a bit more about the WMD, what WMD actually is and why does it matter for the field.
Let me start about like the generally WMD and what it is. So why is it important is that over the last 20 years, every year we are evaluating what's the state of the art, and all the academics and industry can compete with their best machine translation systems and see how far we can actually push the frontier of the research to see how good the systems are. And as well, we are also pushing how to evaluate them. And every year we are improving on the pipeline, because if we would be evaluating them the same way like 10 years ago, we could kind of claim that machine translation already is solved and there is no need to focus on it. So the main important is that every year it's completely new setup, a fresher data set for evaluation, evaluated with humans. And it's kind of like a competition with among the academics and the industry in this realm. And as for what is WMT, so WMT is a conference which also has like multiple shared tasks that focus on different subparts of the whole machine translation field. So from low resource languages, terminology focused translation, post editing, etc. And then there are two main tasks, I would say. The one which is the oldest, it used to be news translation. Nowadays it's a general machine translation, but the main focus of the task is to make the train general purpose machine translation that can translate any domain, any text into subset of the languages which is selected every year differently. And then the other most important task is the metrics shared task or automatic evaluation shared task, which is focusing how can we design automatic metrics that will correctly evaluate how systems are evaluated. And maybe with this, I would give floor to Alon.
So automatic evaluation of translation has become very, very important, because human evaluations are just so slow, expensive, and difficult to run. And there's been many evolving use cases, but two main ones is just for machine translation developers is to be able to drive their research, to know when they are actually, training a new model or a new variant of a model, whether that new model is better than the previous one. You need an automated evaluation system that would actually assign scores and give you that type of information at a granular level as much as possible. And then there's what's become known as QE, which is basically the translation time quality assessment of machine translation or a translation, where the goal is actually to know at translation time what the quality of any generated translation is, so that you can actionably, do things, make decisions on that, whether they're workload decisions, whether it's post-editing decisions, where editors should focus more attention, what can be, pushed out maybe in raw machine translation form and that nature. So those two scenarios, main scenarios of kind of offline contrastive evaluation of for machine translation development, which is known as reference-based evaluation, also typically called as empty metrics. That started first around 2002, and then in WMT starting around 2008, there was a shared task on that. And then QE metrics, which kind of came later, or QE systems, was a separate shared task at WMT, even though there's a lot of similarities. They're both automatic quality evaluation of machine translation, but the two scenarios were different enough and the technologies were different enough that there were two kind of parallel shared tasks for quite a few years. And this is the first year, actually, where we unified and merged both of those things together, because the underlying technologies, particularly with LLMs, for building systems that solve this task, have come together very, very closely together. So this year we did a unified shared task on both reference-based and reference without references, so both metric use cases and QE use cases together. And we adopted fundamentally all of the language pairs and the data set up from the translation task that Tom just described to you a few minutes ago. So 16 language pairs, including low resource language pairs, much more difficult data for the machine translation systems, generating human. So here in these tasks, we do generate human assessments, because that's the gold standard against which we evaluate all these automated translation quality systems. How well they're doing is evaluated against human annotations of translation quality. And predominantly, this has been over the last several years done using MQM annotation. The listeners probably know about MQM, but if not, we can talk about, clarify that. And this year, it was mostly done with a simplified MQM schema that Tom and several other researchers actually proposed a couple of years ago, called ESA. It's basically a simplified version of MQM that allows for a little bit more faster and easier annotation by humans, and hopefully a little bit more consistency between the annotators.
That was one of the major changes this year, Alan, correct?
Yes. So there were several significant changes this year, one of which was the unification of the reference metrics plus and the QE under one unified shared task. So references are optional, and the systems that are submitted can use them when they're there or not use them when they're not there. One was the data setup that we adopted from the general shared task, which much larger, longer segments, so paragraph long segments, and harder data for the machine translation systems. And the third was the human evaluation that's done with primarily with ESA. Yes.
So, Alan, you mentioned that the test sets you used from the empty sorted task were actually harder this year. And Tom, would you like to explain more on the more difficult test sets you used for this task?
I think the one thing that we've been seeing over the last 2 years or 3 years is that there have been more and more claims that machine translation is solved, and then maybe there is no need to push more in that realm, and let's focus on something else. But the actual reason that we as a researchers saw is that, well, we've been evaluating on relatively easy sentences, and especially for the higher source languages. Translating news article or Wikipedia pages is really easy. That's simple language, and you don't need specialized system to do that. And with LLMs, they actually do it perfectly. So what we focus this year the most is how to increase the difficulty, how to focus on something that's actually challenging, not just taking random news articles, but instead we focus, for example, on the news commentaries, some reviews that are more creative language. We focus on the literary domain, which was one long story. We focused on a speech translation. We took videos and transcribed them with automatic speech recognition. So the systems would either have to use the the audio input, or know how to fix the errors that are from the automatic speech recognition. And lastly, we focus also on the social domain, basically user-generated content that contains errors, contains different vocabulary and style. So those being like one of the ways how we try to improve the difficulty. Second is that we also developed the difficulty sampling algorithm, which when you have a large pile of data, let's say that you collect news articles, how to select those that will be more challenging for translation. And for that, we developed the algorithm that can sort them, and basically we took the hardest ones. So once we had all of these more difficult sources, then we asked a human translator to translate them. And for example, from some of their feedback, we found out that it's difficult even for humans. We've been getting feedback back that, oh, I will need more time to translate it. This is more challenging. I don't understand this. Do you have some terminology to support the input? So that was one of the first feedbacks that we got. And later, when we also got the automated systems, we saw that they do struggle more in contrast to last year. So they contain much more errors in the output. So it's the direction that we went. Basically, let's actually focus on something that's challenging and needs more effort to translate rather than simple news articles, for example.
So I want to point out what the consequences of that are on the MT, the evaluation systems here task. So the fact that the content is harder for the machine translation task means also that it's more challenging for human evaluators to evaluate the quality on that content. So our human annotations for gold standard that were developed also for the main shared task, but also for our shared task, were more challenging for the annotators to do. On the other hand, the fact that it's harder for machine translation doesn't necessarily mean that it's harder for automatic metrics to distinguish between those systems, because when machine translation was really bad, it was easy to develop actually metrics that distinguish between them, because it was very easy to tell between good, medium, and bad machine translation. But nowadays, when most of the translation generated by machine translation systems are actually very high quality, and indeed, it's not the case for every of the language pair that we saw this year, especially with the techniques that Tom mentioned for making the data more harder. It's not that everything was still very easy, but for certain language pairs, we saw it was still pretty easy for some of the content types. So now it's actually much harder for automated systems to identify, the small differences between those systems, especially on a segment by segment basis, right? So when we run our task, actually, we have kind of two meta evaluation processes. I don't want to go into too much technical detail, but one of them looks at what we call the system level, which is fundamentally indeed still the ability to distinguish between the quality of two systems on a collection of data that we have, on a collection of documents. And there, because it's aggregated over a collection of data, overall kind of the strengths and weaknesses kind of pop out, and automated metrics can do a fairly good job of distinguishing between the systems in the same way that humans do. But on a segment by segment basis, even with these long segments, it turns out to be quite challenging, both for humans, but even more so for automated systems. And we see that particularly this year. This year, one of the things is that we tried out, we didn't just collect submissions from participants from the outside, but we, the organizers, not only ran some legacy metrics basically to have as baselines and comparisons, but we ran all of the major LLMs with simple prompting as an LLM as a judge for the first time. This is the first time that we actually in this shared task did this. We ran all the major LLMs with prompted to do machine translation quality scoring, and we evaluated how well they do, and we got some interesting results. We can talk about those in a minute in more detail.
So, Alon, would you like to tell us a bit more about the findings this year? I think that the most important thing, or the most important finding this year, is how strong the reasoning-based large language models were as evaluators, correct?
Yes, so for our shared task for the automated translation quality evaluation, I think a few things kind of popped out, and there were also some things that didn't quite expect. But the main kind of headline I would say is indeed we had two very strong LLMs. Both of them were the kind of the latest generation with reasoning that did very well in the evaluation, both at the system level but also at the segment level. I can mention them by name. I don't know if that's important. The findings paper has all the details, and you can actually see exactly who those are. One of those was one of the LLMs that we ran. So and it was fairly basic prompting. The other one was a system that was submitted by an outside participant, where they not only used a strong LLM with reasoning, but they did extensive prompting and setup of the task for the LLM to including very specific examples about how to actually score translations, including detailed instructions about what to generate, etc. And that seemed to be that seemed to work very, very well. That was probably one. We only had very few submissions that actually, to my surprise, actually, I was hoping we would get more submissions of this nature, but we didn't get too many submissions that had detailed prompting with an LLM to do this task. And I think that's clearly, in my mind, where the future is going. So I think, yes, that's probably the highlight of the shared task this year. One of the surprises was actually that we got a lot of submissions that were variants of trained neural metrics that have been very strong performers in recent years, particularly Comet, but not just Comet. There's metric X, and quite a few submissions did some, basically took the baseline Comet and did something, either extended it to multiple sentences or incorporated other types of knowledge or various things like that. And all of those variants of those trained neural metrics did not do very well this year. They were surprisingly weak. And we're still in the process of doing some in-depth analysis to try and fully understand really why those metrics underperformed this year. I have a feeling it's mostly, and we have some smoking guns. Tom was helpful also already on trying to find one highlight there. I'll mention it actually. Maybe Tom, you can articulate even more about this. But it turned out that many of the submitted machine translation systems that were submitted to Tom's task, to the general translation task, were actually tuned on Comet. Basically, they used Comet in the process of developing the variant of their model to hill climb or to improve results. And you get better Comet scores as you do that. But any metric has some weaknesses and biases. And if you just hill climb on a metric, then you're incorporating those biases in the outputs in ways that are subtle and you're not aware of. And then when you evaluate that model and compare it to independent human judgments again, then those biases pop out. And then therefore that model will actually underperform. It will get high Comet scores, but those Comet scores will not agree very well with human judgments anymore. So we think that was one of the things that happened this year, that because many of the systems hill climbed on these these metrics, then it caused the metrics actually to underperform on those systems when data from the system was used for the evaluation. But the other thing is just the radically different data scenario. These really long segments, these low resource languages, the hard data. It may indicate that these trained neural metrics were overtrained for data scenarios that were basically no longer did not match the data that we had this year.
I remember you, Alan, mentioning in a call we had a couple of days ago that Comet became a victim of its own success.
Exactly. That is the case. I think the fact that very many people in the community adopted Comet as the way to do automated evaluation over the last few years, and then used it to train their systems, is is in fact, it is a victim of its own success, because now it is underperforming on evaluating systems that went ahead and did that.
Tom, do you have anything to add to the eval part?
I wanted to just highlight why I think it's critical that evaluation is staying on the tiptoes and keep pushing, and it's more important than even the modeling. That basically this is what we are currently seeing in the field. It's like the classical Goodhart's law problem. That basically the moment that the metric became a target, it ceased to be a good metric. And like since everyone started using Comet as a reward model, for example, or filtering, then the metric can't even catch up. And it's like just one of the puzzles, and like why we need to why it's super critical that WMT is happening every year with new setup. We are updating all the problems that we found in the past, and this is just underlying the importance.
All right, let's go to the performance, right? I mean, we would probably have to screen share because you have so many kind of rankings and tables, and it's always challenging for our production team to reproduce them in our tool. But I guess one of the takeaways is that the general purpose LLMs like Gemini 2.0 Pro and GPT, I think you guys use 4.1, did really, really, really well. So what does that tell us? I mean, compared to some of the other systems like things like Google Translate, etc. Like, what does that tell us about LLM-based translation, where it is today?
So I would say one comparison is basically like you mentioned a couple of production systems like Google Translate, etc., versus the Gemini and GPT. Those are state-of-the-art models that are gigantic, really expensive to run, and of course, if they are best in the class, then that makes them like they've been winning. For example, with Gemini, that was the only model that we run with reasoning on. So that made it like 8 times more expensive, and the reasoning actually improved the performance. While in contrast, for example, some of the other models that we would expect to be on top of the class, those are oftentimes focused on the inference speed, and you can't wait like a minute to get a translation as you get with some of the big models. So that's on the one side, but maybe I would add a little bit more. What I think is really interesting what we saw this year is that how small models built by universities and basically 9 billion models catch up with these top systems, and they are actually ranking among the top clusters. It shows that you don't need a 1 billion parameter model. You can actually do it with I meant
Trillion.
like trillions.
Trillions now, man.
But what I wanted to say is that instead of having trillion parameter models, you can get to 9 billion parameter models, and they actually rank in top. So that opens a lot of room for researchers, especially in the academia and in smaller industry, where you can't train for thousands of hours on a gigantic cluster of GPUs. You can train in a couple of days on a relatively small cluster and get actually close to the state-of-the-art performance.
Maybe first of all, just to add some thought to what Tom said. I mean, fundamentally, nobody trains models from scratch anymore, right? We're all built on pre-trained models, and the question is like, what is the starting point, and like what is done, on top of that, and for what purposes? And I think what's true is we're going to see that in order to get very good translations for very specific use cases, domains, type of language, and things like that, you can do that even in academic institutions and things like that by specializing models with a strong starting point. And the starting point, that the big guys worry about, pushing the envelope with the latest models and the most general models and the most multilingual performing models, and then other entities. The ecosystem is kind of changing. What you can do with academic institutions, smaller companies that specialize in certain things is kind of changing. The other thing I think is still kind of interesting is the multilinguality aspect of this. For the very large, economically viable language pairs where there's a lot of data, MT has really gotten really, really good. But these LLMs in particular, a lot of them break down multilingually in performance, including in translation, and not just in translation. When you move to smaller second tier and smaller languages, And part of the interesting thing is that a lot of these pre-trained LLMs, they're trained on the entire internet. And of course, they consume data in all of these languages wherever it exists. But they're not, in many cases, they're not specifically built in order to truly be multilingual from the get-go. It's kind of almost like an afterfact or kind of a nice surprise that they actually are capable of translating and that they are capable, their multilingual capabilities are what they are. But there's a lot of interesting work on actually making them much, much stronger multilingually, especially for lower resource languages. And then on the evaluation side, again, I think we see sort of the artifacts of that. We see that indeed you will be able to get very detailed actual error annotation, automated error annotation, equivalent to ESA or to MQM with very detailed prompted reasoning models, but they are going to be expensive to run. So the question is then, how do you actually then distill that or create models that are much more scalable, kind of leaner, faster, and more economical to run? And we're in a transition from this earlier generation now of neural models that do QE, that all the kind of commercial providers are fundamentally have models like that that generate scores, but those scores are not quite as accurate, I think, already to the scores that you can get. Well, the evidence shows that they're not quite as accurate as what you can get from LLMs. And so there's going to be indeed exactly what Tom was saying, that trade-off between, slower, expensive models that are very accurate in their quality performance versus, scalable, faster and cheaper models to run. And that transition is going to happen, I think, over the next few years.
Very interesting. I would like to go back to Tom about another interesting finding from the MT short task. We saw that human translation didn't land in the top cluster, Tom. How should we interpret the results? I mean, we might have some headlines about human parity.
That's a great question, and I'm always pushing back with any findings kind of with WMD because there is a way more open question that we got with this than rather answers. And instead of saying that we crossed the human parity, I think it's the issue is that the translators that are translating out the set are humans, and we are using professional agencies to translate this test set. But yet those are translators doing 40 hours a week translation. So they get tired, they are pushed by the deadlines, but they have some limited time. So that's one way which reduces the quality. Second, it could be that basically we are kind of forbidding them to use any pre-translation. So they can't do post-editing. They need to do it from scratch, which could affect the way how they work, because nowadays most of the translators don't translate from scratch. So there is more of these open problems on how, if there are errors in the translation. And then there is also the human evaluation, where we kind of see that human annotators pressure the outputs of LLMs rather than humans, human translation. Despite if they need to assign the errors, the human translation usually has less errors. But if they are assigning like which way they like more, they go for the LLM. Maybe because it's more fluent, maybe because it's smoother. We don't know, but those are these various stuff that we see from it. And so I would be really careful about claiming human parity. I don't think we have human parity. Maybe we at some point will reach some like human parity on a tired translator doing it 40 hours a week at the evening on Friday. But it's more about like how can we make it maybe next year better and improve the setup for the humans so they actually can do better job. Or maybe we can allow them to use the post editing. Maybe we can actually force the human annotators to mark the errors, and if they don't mark error, they are not allowed to give lower score. So something like that.
I think that the human translation and the human, particularly the human evaluation, has become sort of the Achilles heel or the weakest kind of the weakest kind of thing in this entire setup. I mean, we're getting to a point where it's just getting very difficult to get really, really good, reliable, consistent and human translations and human annotations. that with which we can compare basically what the automated systems are doing. Because if we don't actually have a really good, strong gold standard to compare with, we're basically just shooting in the dark or kind of swimming in a fog, right? We cannot assign really good assessment to what machine translation systems are doing without knowing basically what is right and what is wrong. And they're all getting so good at this point where it's getting very difficult to get very accurate human annotations and human translations against which we can compare and trust that comparison is actually meaningful. So there's one of the, I think, the most difficult challenges that I think Tom is thinking about this too, but we're really thinking about is how do we actually move forward in this world in which it's so difficult to generate gold standards against which to compare with. How do we improve human translate? Do we just get rid of human reference translations or human to compare against? What would replace that? How do we get human annotations of detecting errors to be consistent and reliable and high coverage in terms of not missing errors, right? When there's so few errors, it's so easy to miss an error here and there, and the annotators do that all the time. They don't so much disagree about errors. It's not that annotator one says this is the error. No, the annotator says no, it's a completely different error. That doesn't happen. But annotator one misses some fraction of the errors, and annotator two misses some fraction of the errors, and they each miss some different errors.
Exactly, very important, very interesting. Let's now move to the next question about the actual deployment. And this question can go to both of you. So for teams deploying AI translation and evaluation in real workflows, what should they take away from this year's results? What actually matters in practice?
Evaluation methodology is changing, and it is actually a challenge for a lot of particularly practitioners and enterprises and providers to actually adopt methodology and automated processes that know how to actually leverage these systems that we basically find are performing well into repeatable processes. I think one of the challenges there is that, again, in practice, there are different use cases and applications for things like machine translation, automated translation quality evaluation. If you're doing QE, for example, as part of a workflow in order to decide basically how to route content, then you need an evaluation that will look at the system that's generating QE scores and see its effectiveness in doing that kind of routing that you want to do. So for example, maybe you want to just identify the documents or the pieces of content that meet a certain quality threshold and send those out without any human review or without any human editing. So create a testbed scenario that looks at how well a QE system or an LLM as a judge is capable at doing that triage of the best, the highest quality versus all the rest. Or maybe you have a limited budget, and what you're most interested is, putting your post editors on the lowest quality translated documents, right? So in that scenario, it's a different triage, right? It's identifying the lowest quality reliably. So you have to set up actually a workflow or a scenario that will evaluate the specific automated translation quality QE system, regardless of who the provider is, at its ability to detect the lowest quality documents or the lowest quality segments, right? And we don't actually have a published blueprint that is, just out there for everyone to follow, and for this, an exact recipe to follow in evaluating different different technologies or different systems available on the market for these different types of use cases. And I think that's actually a gap that I'm looking to try and address. We're going to try potentially forming a working group across the industry that is interested in these types of questions and maybe can come up with some guidelines or recipes about how to evaluate the performance of automated translation quality systems for these specific commonly used use cases.
With Cohere, I mean, you guys launched, Command Translate so recently, which I think does the general family of Command, right, would address the multilinguality from kind of inception that Alon before said is a bit of a problem. But okay, going back to the original question. So your takeaways for maybe Cohere from something like from WMT, like as a practitioner, are you bringing this back? Are you talking to product people there, to other researchers? How does that work?
That's an excellent question. I would say that maybe I'll answer a little bit from the modeling side of the house rather than the evaluation. So one of the points is basically how to improve on them, how to know that we are improving and what to do. So unfortunately, so what we saw from WMT is that reward modeling, filtering with Comet works. There is MBR. There is plenty of techniques that actually works on the modeling to push the performance. But the key point is more about what to trust. As Alon mentioned, that so for example, the human evolution are still gold standard. So it's much more difficult to bias humans to judge the systems. There are basically, so maybe my main answer would be that if you're a practitioner in a company and you do not train your own models, you need to be really vigilant about how to evaluate them. So if you don't know how it was trained, it can be biased towards your evaluation. However, if you build your own models, then the key takeaway is, for example, don't use the same metrics that you use for if you use Comet in somewhere in the pipeline, do not evaluate it on it, and maybe go with LLM-based metric as LLM as a judge. And basically what I think is the main feedback is more about convincing, for example, if we would be selling the Command A Translate, is getting customers on the side that we need to evaluate on difficult test sets. So for example, not evaluating on Flores on German, just because for those who don't know, Flores is Wikipedia articles. It's amazing resource for low resource languages, but most of the people and papers are using it for German, French, Spanish, Italian, Chinese. For these languages, it's overfitted and there is no progress. And then, for example, if you would have a customer who came and on the Flores and on Blast score, you are this bad and bad, then WMT could be used as a platform to show maybe that's not ideal evaluation. Let's compare on something reliable or more difficult or more even advanced.
Makes sense. Want to close on a couple of big questions or a series of big questions. Alon, let's say Safaba 2026. You're starting again. What's the frontier? What's the current frontier in AI translation? What areas for growth are there for anyone offering it at this point in time, or maybe wanting to start? What are the big remaining unsolved problems? And I said it was a series. Why do they remain unsolved 3 years into the LLM revolutions and, hundreds of billions and soon trillions of dollars spent on this and nuclear reactors powering all of this?
Okay, those are hard questions. But they're two separate ones. If I were to start a Safaba today, or what is something that is interesting? So I think personalization. I mean, we already know that it's becoming very much easier to actually adapt translations for specific scenarios by providing the context and providing detailed information. You can basically bias or instruct the LLMs basically to generate translations that are very specific. And I think there's lots of opportunity for personalization, particularly in marketing situations where you're tailoring to specific communities, to specific groups, but all the way to even personalization. So you can have a situation in which, instead of companies just translating, a particular content, say marketing content, into a target language in which the company is operating, it actually generates on the fly a translation for you, knowing everything that it knows about you, so that translation is going to be much more, impactful, and particularly in situations where they're trying to persuade you to buy something, for example, right? it will have immense impact on persuasion and things of that nature. So I think there's an opportunity there for technology to in that very, very detailed level of personalization. But like unsolved big problems, I think the ability of these systems to still really self-reflect the way that humans do and check themselves. Like, why are we still in a world in which the machine, the LLM that's generating the translation doesn't already know everything that there is to know about the quality and doesn't generate errors to begin with, right? Why are we still in a world in which we have to have a separate system for measuring translation quality, and the translation system itself is not self-reflective or capable of avoiding making those errors or knowing, how confident it is exactly about what it's generating. And those are fundamental questions about the way that these neural systems fundamentally operate, right? And, do they have, enough self-consciousness about what they're doing, I think the answers to those things are evolving. We don't quite understand them yet, but there are fundamental things about the way these models operate that we still don't quite understand, and therefore there's fundamental things that we haven't been able to solve yet.
Throwing them a bunch of harder problems like what you're doing, Tom, is probably going to be a lot more helpful, right? Than trying the same thing again and getting these scores, getting super high scores, right? I mean, part is to give the systems a ton more challenging tasks to solve. Anything you want to add here, Tom, to close us out on current frontier, unsolved problems, thoughts about the future?
Alon summarized it nicely. Like, my first thought would be some personalized translation. So it's just pushing the state of the art is not like the frontier that I would focus with if I would start a new company. I would focus on the personalization, basically adding more context. Like, if you have the marketing campaign, here's the context, here's the target country, do translation that will be targeted for this. It's like focusing on models that can do more than translation, being more multilingual, focusing on other tasks. Secondly, maybe something new to add to the discussion is I would focus more on agentic and combining multiple systems, and maybe not focusing on how to make one system the best in everything, but actually, contrary to Alon what says that having one system that I can rely on being the best in quality estimation. The second is amazing in translation of the terminology. Other one would be perfect in like Slavic languages. So basically combining them together and knowing which one are relied for what, putting them together could be actually a way how to improve on all of the fronts.
I don't disagree fundamentally. I think that the two things are complementary, but specialization is clearly, much, much easier. And, with agentic systems, specialized agents interacting with each other, very powerful, no doubt.
Maybe just one last thing there. The agentic thing kind of puzzles me sometimes, because what if one part breaks? Don't you add a lot more potential for error? Like if one gets it wrong, one of these agents, you have like a failure cascade throughout all the other agents?
Not necessarily.
No? Okay. They can self-correct.
Well, yeah, or another agent can basically check and verify the work of the first agent. So when the first agent makes a mistake, there's going to be another agent that has a different perspective and specialization that will catch the error and flag it or correct it, etc.
Awesome. This was great. Thank you so much. Thanks so much, Alon. Thanks so much, Tom. Thanks so much, Maria. Thanks for taking the time today. And thanks for all the great work you do with WMT. Super, super valuable. Thank you.